Alright, this is lesson 77, Arithmetic series. Students will write and evaluate the sum of a finite arithmetic series. So that does say finite, not infinite. Okay. So infinite means it goes on forever. Finite means it has a beginning and an end. Okay. So we're going to be taking what we learned last week, which was a sequence of numbers. Remember last week we talked about 2, 4, 6, 8, 10. Next number is 12. Good. Okay. Right. Let's pretend that now we're not writing a sequence, but we're taking that sequence and we're adding all the numbers together. So that's called a series, okay? And we're going to be adding numbers together and figuring out what the sum of all the numbers are. Okay, so we use this in real life. For example, you might personally look at your own money and be like, okay, when you're an adult, you're like, oh man, every month I am down $600. That means after all the money you make and after everything you spend, you have negative $600 every month. And so you add up how much money you're going to have at the end of the month, and you can figure out, uh-oh, I'm going to be out of money within 10 months, okay? Or it could be another example. It could be, let's say you're an accountant for a corporation. This happens too. Corporation figures out its cash flow, and it says every day we have this much money. On this day we'll have this much money. On this day we'll have this much money, and then this day we're going to make this much money, this day is going to be making this much money, and hopefully you're making more and more money every day, and there is a sequence of numbers that you're adding as a series, and you're noticing, I'm going to have this profit at the end of the year. So they project a profit, the accountants make a report, and they tell their shareholders, we're going to have this much money at the end of the first quarter. And then people on the stock market are like, yay, we like your stock. Or it could go the opposite way. They could be losing money. They'll say like, hey, we're gonna be losing $6,000 a day for the next 100 days, so that's $600,000, right? They'll add up all the days that they lost money, and then they tell their stockholders, and the stockholders will be like, oh, that's not good. They'll sell their stocks. Or another example is the accountant could say to their manager, like, or to the CEO, we're going to be out of money at this point. And so the CFO and CEO and the executive board and board of directors will apply for bankruptcy. So this is actually used every day. So those are a couple of examples. These are the steps, but I'd like you to look at down here at this step E. Right here for me, please. I want you to change something for me because it's kind of my computer. I don't know why it's presented this way. I want you to change, this is, by the way, sigma notation, but the number up here, this is U. Put the U on top. This is called the upper limit. And L down here, this is called the lower limit. And then the explicit formula we already learned. So we're going to take a series of numbers, we're going to add them together, we're going to be talking about this sigma notation, this E, it's called sigma, okay? That's the Greek letter for it, and it's called sigma, and it represents a sum of numbers, okay? Sum, it means add, right, sum. We're asking ourselves, what's the sum of all the numbers from the lower limit to the upper limit when we use the explicit formula to find each number, okay? So I'm going to actually jump to number 5 today first. I'll do one problem. I'll show you how to do it. It's pretty straightforward. And then we'll do another problem together. And then we'll jump to another. I'll show you an easier way to do it. And then I'll show you the way we write it, okay? So I'm jumping to 5 first because you kind of need to know where we're coming from first before we start. Okay, so use summation notation to evaluate the following series. Okay, so let's say we're at number 1. What this is saying is when we see the big sigma letter, we're saying what's the sum of all the numbers from the smallest, which is the first number, all the way to the 5th number, if this is our explicit formula. Okay, so what that looks like is we're saying what's the first number plus the second number plus the third number plus the fourth number plus the fifth number, okay? That's what it's asking. What's the first number, second number, third number, fourth number, fifth number when we add them all together, okay? Well, we don't know what the first number is, so this is our rule. This is the explicit formula for the rule for the first number. So we're going to write down the explicit formula, which is 11 minus 5k. And instead of k, we're saying that k, the first number is, or this is the first number, so k is our first number, so we're going to put in 1 instead, okay? And then we're going to do that for the second number. We're going to add the second number, which is 11 minus 5k, or 5 times 2. Okay? Then we're going to do that for the third number, which is 11 minus 5 times 3. Plus 11 minus 5 times 4. Plus 11 minus 5 times 5. Okay? So you could see it takes a little while to write them out. Now how do we figure out the first number? 5 times 1 is 5. 11 minus 5 is 6. Plus 5 times 2 is 10. 11 minus 10 is 1. Plus 5 times 3 is 15. 11 minus 15 is negative 4. So we're going to add a negative 4. Plus 5 times 4 is 20. 11 minus 20 is negative 9. We have one more number. 5 times 5 is 25. 11 minus 25 is negative 4. Okay. So now what we're going to do is we're going to add all the numbers together. 6 plus 1 is 7. 7 plus a negative 4 is 3. 3 plus a negative 9 is negative 6. Negative 6 plus a negative 14 is negative 20. Okay, that's your answer. That means the sum of all the numbers from the first number to the fifth number with this rule is negative 20. Does that make sense? Yeah, kind of. Okay, or another way you could look at it is, let's say you start off with making $6, but every day after you're going to be making $5 less, because that seems to be the difference. How much money will you have after 5 days? Negative $20. That means you owe someone money. Okay, so why don't we have you turn to your neighbor today. Let's have ones tell the twos how I figured this out first, and then we'll do number 6 together. Ready, set, go. Okay, so please write down number 6 now. Let's do this one together. I'm going to erase 5 or hide it. Okay, so number 6, what is it saying? It's saying that we want to find the sum of all the numbers from the first number all the way up to the 8th number, okay? So on your problems, for the most part, you'll start off on the first number, but we want to know what is the answer to adding up all of those, okay? So basically what we're asking ourselves is the following. We're asking ourselves, what's the first number plus the second number, plus the third number, plus the fourth number, plus the fifth number, plus the sixth number, plus the seventh number, plus the 8th number. Okay? Right? It takes a little bit of work here. And then we're going to take the first number, which is, we're going to use the explicit formula, 9m minus 6, but instead of m, we're saying the first number is 1. So it's 9 times 1 minus 6 plus our second number. We're putting that into parentheses. 9 times 2 minus 6 times, or plus 9 times 3 minus 6 plus 9 times 4 minus 6 plus 9 times 5 minus 6 plus 9 times 6 minus 6 plus 9 times 7 minus 6 plus 9 times 8 minus 6. Okay, can you please evaluate these? So you're working with your neighbor, figuring out what each number is, and then you're going to add them all together and give me the answers. So remember to do PEMDAS here. You're working out each number, so Here's the strategy. 9 times 1 is 9. 9 minus 6 is 3. So this is 3. Okay. Right, 9 times 1 is 9 minus 6 is 3. Next one, 9 times 2 is 18 minus 6 is 12. And so forth. See what was going on? So we're adding 9 every time. So let's give you plus 21, plus 30, plus 39, plus 48, plus 57, plus 66, right? So right, 1, 2, 3, 4, 5. You add them all together, you get 276. Okay? All right. Now this is kind of tedious, right? Raise your hand if you agree that this takes a lot of work. It's tedious, right? Totally is tedious. We use this notation, sigma notation in math, because we're representing all of this in this, right? But what if this number was not like, let's say the lower limit was 1, but let's say the upper limit was not 8, but let's say it was like 33 or 52. Would you sit there adding up 52 numbers? No, that would be very hard and tedious, okay? We like using this notation, but if that was the case, we would not want to use this method to solve the answer. There's a different method now. I want to show you the next part of our lesson. So I'm going to jump back down to number 1. Okay? So number 1, this one is saying find the sum of the arithmetic series. Okay, so let's say that this was, it gave us some information. This is a different way to present it too. Okay? We said that the first number in our series is 30, the last number is 66, and there's a total of 5 numbers. Okay? So what this is saying is, what's the answer if I were to add up 5 numbers, knowing that there's the first number plus the second number plus the third number plus the fourth number plus the fifth number, right? If let's say that was what the concept we're trying to figure out, and then we knew that the first number a sub 1 was 30, so we didn't have to use an explicit formula. And we knew that the last number, a sub n, which n is equal to 5, is 66. If I were to add up all these numbers, right, we don't know all the middle numbers, and we really don't need to know all the middle numbers. So we use this thing called the sum of a finite series formula, which was on your notes. I think it was step 3. Which is basically the following. We have s sub n is equal to n over 2 times our first term a sub 1 plus our last term a sub n. So we plug in our numbers. We know n in this case, the number of numbers is 5. So we're going to put a sub 5 is equal to 5 over 2 times the quantity of our first number, which is 30, plus our last number, which is 66. And then we use PEMDAS to evaluate this. So parentheses first, 30 plus 66 is 96. Right? And I could use my calculator, or I could just simplify at this point. We know that 96 we can make a fraction. This is a multiply problem, so I know 2 goes into 96 twice. It's 48. And over here we have 1. So 5 times 48 and 1 times 1 is just going to be 240. That's our answer. That means that I wouldn't have to write all the numbers out. I could just use this formula to figure out that if I were to add up all these numbers, it's 240. Okay? Does that make sense? So on a problem like this, it's a lot easier to use this particular type of formula. Because look at number 2. How many total numbers are there? 25. Are we going to write 25 numbers out and add them all together? No, that would be ridiculous, right? So we're going to use this formula. So, yes?
Where did the 5 go from S5?
S sub 5, that means the sum of the 5. This notation means the sum of the 5 numbers is 240. We're just assuming it's there. Okay? So what I'd like you to do, let's switch it up. Let's have the twos talk about how we solve a series of numbers, how we add them together using this notation, and why it's important to use this notation. Remember the importance of it if we have a large set of numbers. So please explain that to your neighbor. Twos are talking to the ones or no. Ready, set, go. Okay, so number 2 is asking us a similar problem, Okay, it's saying, let's say we had a first number in our sequence was 13. That's the first or lowest limit. The upper number was 133. And we knew that the upper number was number 25 in the sequence, meaning there are 25 total numbers we're adding up, right? That's a lot of numbers. So, we do what we did before. You don't have to write down 1 plus 2 all the way to plus 25. We're just going to start off with our formula, which is S sub n, or the sum of a series, is the total number of numbers times the first number plus the last number. Okay. We plug in our numbers. So we got n is equal to, in this case, 25. So we're saying the sum of 25 numbers is equal to 25 numbers divided by 2, all times the first number plus the last number. Okay, so I'll write those down, and I want you to solve this and show me on your Doceri app what the answer is. Okay, ready, set, go. So again, if you were to put this in your calculator, you'd want to do PEMDAS. So 13 plus 133 is 146. And then you're going to multiply that value times 25 and divide it by 2. And you get, again, what's the answer? 1825. Was that what you guys all got? Yeah, that sounds familiar to me. I did that first period. Okay? Alright, so that's the easy way to solve, okay? So you need to know how to solve remember the sigma notation? And then you need to know how to solve it this way. This is a lot better to use, okay? Now, what happens if what would happen if we just needed to write down a sequence, or I'm sorry, a series in sigma notation? Well, we need to know how to do that too. So remember what we did. This is the last part of our lesson. Let's say we wanted to write down a number in sigma notation or a sequence. This was the initial problems. How do we do that? Okay, that's the next thing. Okay, so here we go. Use summation notation to write the following terms. 4, 8, 12, 16, 5. We know that there are 5 terms. We want to know how to write it for 5 terms, okay? So the first thing you want to do is we want to write the summation notation, or sigma. So we write down sigma first. And the way you write down sigma, this is the easiest way. I know kids always struggle with this. Just draw sideways M. Oops, sorry. So I like just drawing a couple lines and then I just draw an M. See how that's sideways? Right, if you turn your head. Okay, then we want the lower limit. We have a first number is our lower limit. We say it's 4, but the first number is really the first number, which is 1. And then we are a total of 5 numbers. Okay. Now the explicit formula here is a little bit tricky. We need to figure out what the difference is. Remember a few days ago we did the explicit formula. So what's the difference between the numbers? 4 plus 8. Or plus 4 is equal to 8, right? 8 plus 4. So that's our difference. That's part of our explicit formula. So that we know that each number will be added or multiplied by 4. Right? Now this is a little tricky. How do we get the first number? If I know my first number is 4, what should I add to get 4n? Well, 4 times n is 4, so how do I get 4 if 4n is 4? I would put a 0 here. Okay? So a good way to think about how to get the explicit formula for summation notation, I know I told you a different explicit formula a couple days ago. This is a little bit different. You take the first number and you subtract the difference to get the first number, and then you add the difference times n to get your explicit formula. Complicating a little bit, okay? So it's really important you think conceptually, okay? That's why this is kind of a little bit harder. So again, how did I get this? In order to get the first number, you take the number we're talking about, which is 1. 1 minus d, which is 4. So our first number is 4. 4 minus 4 is 0. Okay? The first number, and then we take the first number, 4 times n, and we write that down here. Okay? Alright, so let's have 1s and 2s talk about how I did this one, and then we'll wrap it up by doing one more example. Ready? Go. summation notation, which is sigma. So draw a sideways M. Okay, what's the smallest number or the lower limit? 1, right? What number are we starting with? The first number, right? So we're saying n is equal to 1. What's the largest number or the largest number of numbers in this sequence? 33. Okay. And we want to add all these together, so we start with our explicit formula. So we have a couple numbers we have to figure out. This first number, remember, we have to figure out what is the first number minus the difference. Now we have to figure out the difference. What's the difference? What's the common difference going across this whole sequence? Plus 9, right? So if our difference is 9, we're going to take the first number and subtract 9. So what's the first number minus 9? 11 minus 9 is? 2. Good. So we're going to put 2 here. Okay. Then we want to add the common difference, right? Because we're going to take the common difference times n. So the common difference is 9 times n. That's it. We're done. And then we just double check. Let's just check the first number. 2 plus 9 times 1. What's 9 times 1 is 9. 9 plus 2 is 11. Is my first number 11? Yeah, good. Let's check the second number. Okay. 9 times 2 is 18. 18 plus 2 is 20. Is my second number 20? That means you did the explicit formula correctly. Okay, so you definitely want to check your work. It doesn't have to be like you have to write it down, but I want you to make sure you get the right answer. Okay, don't just guess on your homework. Make sure you own math. Okay, use it for. Make sure you get it correct. Okay, and that's it. All right. There's a lot of different topics here I did today. They're all together with the summation notation and finding the sum of a sequence. So I want us to think about what's the difference between a sequence and a series. Last week I taught you sequence, today I taught you series. What's the difference between the two? Yeah.
Series is finite.
Okay.
Yeah.
Well, you could have a series. Or sequence, you could have an infinite one. Yeah.
As a sequence, you're going up, you're adding the same number over and over.
We're not adding the same number over and over, no. Okay, last week, sequence. 2, 4, 6, 8. What's the next number? 10. 2, comma 4, comma 6, comma 8, comma 10. Okay. Today I taught you summation notation or sigma. Okay, so instead of 2, 4, 6, 8, 10, it's going to be, what is the sum of 2, 4, 6, 8, 10? So what's the difference between a sequence and a series? Instead of just a list, right? Okay, good. So the different sequence is a list, okay? Did y'all hear that? So if I wanted to list all the numbers, 2, 4, 6, 8, 10. Okay, if I wanted a series, it's the addition problem or the sum of all the numbers. So 2 plus 4 plus 6 plus 8 plus 10. That's the difference, okay? Did y'all get that? Yes? Okay, so turn to your neighbor, explain one more time what's the difference between a sequence and a series. Make sure you got that before you leave, okay? And then we're done with the lesson.